Many games have a save system. It's like a little time capsule for all your hard-earned progress, achievements, and settings. Developers use these save systems to store all sorts of data to make sure your hours of grinding don't vanish into thin air. So, how to make a save and load system in your own game? Today I'm going to use Godot as an example and show you probably the most easiest save system you ever make. We're going to use Godot's built-in config file to store some simple player data, and to keep things safe, we're also going to encrypt these files so no one can tamper with it. So, are you ready? Hit the subscribe and like button and let's get started. Alrighty, today I've got this super simple UI to show you how to make a save system. We'll be saving two very basic pieces of info, the player's name and the player color. Since this tutorial is all about the save system, I'm not going to dive into how I built this UI step by step. If you want to get creative, feel free to design your own game scene or UI. Or if you're feeling lazy, I got you. There's a link in the description where you can grab this template and follow along. So here's what we got right now. If we exit the game and come back, all the stuff we said earlier is gone. But don't worry, we're about to make them work in a short while. First up, we need a script to handle our save and load operations. So on the root node of our scene, let's go ahead and create a new script. I'll rename it and click create. Now here's a basic idea behind our save system. The script will read the data we want to save and store it as a file on the player's computer. The next time the game starts, the script will load that file, bringing back all the saved data. Step 1. Let's make sure we can read the player's info. We'll start by grabbing the player's name. In our UI, the player's name is stored in the line edit node. This little node lets the player type a string like their player name in a text box. Back in our script, we first need to create a variable, say player name. Now it's important to tell Godot that this is a line edit type variable. So we need to add a column and specify line edit. But just creating a variable isn't enough. If we save the script and check the node in the inspector, we won't see this variable listed yet. To fix that, we need to add an add_export keyword. This magical keyword makes sure the variable shows up in the Godot editor. Save the script again, and bam! You can now see the player name variable in the inspector. Click on it, and the window will pop up asking which line edit node in the scene you want to use. We've only got one line edit in the scene, so just select that and you're all set. Now let's make things interesting and actually read the player's name when they hit the save button. Start by selecting the save button node, and in the inspector on the right, switch over to the node tab. Scroll down to the signals panel and here's a list of signals this button can emit. We're looking for the press signal. That's the one that triggers when the button is clicked. Double click on it and the window will pop up asking where to connect the signal. Make sure to choose the canvas layer node because our script is attached there, and for the function name, let's call it save. Hit create and Godot will automatically add a save function to your script. Now every time you hit that save button, the code inside this function will run. To start, let's just try printing out the player's name. In the save function, add a simple print statement to print out player name.txt. Save the file, hit F6 on your keyboard to run the game. And let's test it out. Enter a name for the player. Click the save button and look at that. The player's name is printed in the game's output window. Nice! Next up, let's read the player's color. In our scene tree, the color picker is stored in a node called color picker button. So when we create a variable for the player's color, we also need to tell Godot that it's a color picker button node. And don't forget to add the add_export keyword so it shows up in the editor. In the save function, add another print statement, but this time we're printing out the color by accessing the playerColor.color property. Save the script, and don't forget to link the player color variable to the color picker button in the inspector. Now run the game again. Set a name and a color. Hit that save button and check the output. You'll see both the player's name and their selected color printed out. Boom, we're making progress. Next up, we need to save the data on the computer's hard drive. We can do this by using Godot's config file feature. Config file lets us store a lot of Godot data types as a file. First, we'll use the config_file.new function to create an empty config file object and save it in a variable. Let's call this variable config. Now to save data, we use the config.setValue function. This function takes 3 arguments. The first argument is the section where we want to save the data. In multiplayer games, you might use this to distinguish between player 1, player 2, and so on. But for our case, we'll just name this section as settings. The second argument is the name of the data index. Config file uses this index to look up data in a specified section. Since we're saving the player's name, I'll name this data as name. The third argument is the actual data we want to save. I'll take the player name text from our print function and let Godot save the player's name. We also want to save the player's color. On a new line, we use another setValue function, saving it in the same settings section, calling the data color, and storing the player color.color property. Now there's one last super important step. We need to use the config.save function to actually write the data to the hard drive. This is what makes sure the save file gets created, and next time we run the game, we can load it back. We'll need to tell Godot where to save that file. Here I'll use the user path. This path safely stores data in a folder that's not inside your game's root directory, meaning that even if your game gets updated, deleted, or moved, the saved data will still stay intact. We also need to add a file name after the path. I want my data to be saved in a file called settings. The file extension doesn't really affect how config file works, so I'll just go with this .cfg extensions here. Finally, let's add a print statement to notify the player that the data has been successfully saved. Save the script, run the game, enter a player name, set the player color, and hit save. Boom! Godot will let us know that the data has been saved successfully. But where did the save file go? Remember the user path we used? In Godot, this path refers to different folders depending on your operating system. On Windows, the user folder is located inside the app data folder, specifically under the roaming directory. If you're on another operating system, you can check the official documentation for your system's equivalent path. I've also linked the documentation in the video description. For Windows users, hit Windows plus R to open the Run dialog, then type %appdata%. Make sure the capitalization is correct, and hit OK. This will take you to the roaming folder inside app data. Find the Godot folder and open app user data. Each of your Godot projects save data in here. My project is called Simple Save Load, so I'll open the folder with the same name. And there it is, our settings.cfg file. Right-click on it, choose to open it with Notepad. Inside, you see the data we saved. Everything is neatly stored under the settings section, with the player's name and color saved as we expected. Now let's dive into loading the saved data into our game. Back in Godot, find the load button. Just like before, we need to connect its signal to a function. Open that signal panel on the right, find the pressed signal, and double-click it. Make sure the canvas layer node is selected. I'll name the function as load and click connect. Godot will automatically generate the function for us. Inside the load function, the first thing we want to do is to create a new empty config file object using config_file.new. Save it to a variable called config. To load the data, use config.load. Don't forget to provide the file path, which should be the same as the one we used earlier. The config.load function returns a result that tells us if the loading was successful. If the file is corrupted or doesn't exist, it will return an error. We can save this result in a variable called result. Next, we want to check if the result was successful. Using an if statement, check if result equals to OK. We can set the player's name using playerName.text equals to config_file.getValue. The getValue function works similarly to setValue. We need to use the same section and key names to fetch the saved values. So to retrieve the player name, we'll get a variable name from the settings section. Next, we'll load the player's color by using playerColor.color equals to config_file.getValue. Again, fetching the player color variable from the settings section. If the loading fails, we'll print an error message. Use print ERR to notify the developer that something went wrong while loading the save file. Alright, save the script, run the game, and hit the load button. The player's name and color should load right up. If you change the name or player color and then hit save, the new data will overwrite the previous one. And if you go to the File Explorer and delete the save file, then try to load it again, Godot will give you an error, indicating that something went wrong with the save system. Congrats, you've already got yourself a simple save system. But here's the thing. Right now, the save file isn't encrypted. That means any player can open it up and easily mess with the data. If they change something like, say, their player name, we'll be reading their tampered information when we load the file in Godot. If you don't want players pulling sneaky moves like that, we can add encryption to the file system. The encryption feature uses either a packed byte array or a string as a key to secure the file. When reading the file, you need to use the same key to decrypt it and access information. Back to the code, let's create a variable called key to store our encryption key. I'll use a string type here. A string key can be pretty much any sequence of characters. I'll keep it simple for now. However, when developing your own game, it's best not to hardcode the key directly into your script like this, because if a user unpacks your game, they will be able to find your key. Using encryption is super straightforward. We just need to make two small changes. When saving, we replace the regular save function with save encrypted pass. Then we pass the encryption key as a second argument, and boom, your file is now encrypted. Likewise, when loading, we switch out the load function with load encrypted pass and use the same key to decrypt the file when reading it. Now save the code and run the game. If we enter player name and choose the player color, then hit save, we'll see the player data is successfully saved. And here's the cool part. If the player tries to open that save file, they'll just see a bunch of nonsense characters thanks to the encryption, so no more easy tampering with the data. Finally, let's test reading from the encrypted file. Click load and bam! The data we saved earlier gets loaded right back up, just like magic. Alright, so that's how we build the simplest save system in Godot. We use the config file feature to safely save the game data in system path and even encrypt it with a key. While today we only work with the string and color data, config file can handle most of Godot's variable types like int, bool, vector2, custom types, and even node states. Although it's not ideal for saving huge amounts of data, its simplicity makes it perfect for small games. And of course, config file isn't the only way to save data in Godot. There are other methods like using JSON or binary serialization, which are better suited for saving more complex data, but they require a bit more setup. If this video helps you out, don't forget to like, comment, and subscribe. You don't want to miss out on my future game dev tutorials. See you in the next one, and bye bye.